Thanks for coming, everybody. So we're going to talk about Kubernetes-powered platform engineering. We're going to talk about really Kubernetes-enabled platforms. We'll get right into it. I also don't have my speaker notes, and a lot of these are sort of splash pages, so I'm going to wing it. So one of the missions with platform engineering is to abstract complexity. And I think the reason that we do that is to simplify things and to accelerate velocity. One of the things that we have to do is actually respect the complexity underneath. I think often we are abstracting complexity away and taking power and agency away from potentially from developers using a platform. What we actually want to do is sort of define a new way to embrace that abstraction. We want to build simpler workflows, not get rid of the complexity. I'd say complexity can neither be created nor destroyed, right? You can defer it, you can embrace it, or you can abstract it. So one of the things that we're doing here with a platform is we want to abstract the complexity to enable better workflows, to accelerate our teams to build and ship. And my belief, and others that I work with, we've been talking about this for several years, is that the system is actually the thing that matters. Right, so we use Kubernetes. Why do we use Kubernetes? It has a lot of characteristics that work really well for us to build systems. We think of this as the platform, but the platform and the software it operates and the software that runs on top of it, that's the system. So what we want to do is think about the characteristics of the components that go in to build the system and make sure that the characteristics are ones we want to live with. What does that mean? Well, typically these are the bullets we all look at as the cloud-native ideals, right? And we've iterated on this over time. These are all effectively implementation of DevOps best practices, the way you cultural transformation into DevOps teams. What does that mean for our systems? We looked at things like declarative configuration, continuous reconciliation, this checklist of things that we all know are good things, but why are they good things? They serve a purpose, right? We're doing all of these things. We built things like Terraform or even Ansible before that, right? Out of necessity. We wanted to do CI/CD. Why? Because we wanted to ship software faster. Well, how do you do that with bash scripts and duct tape? You can, but Ansible was better, and then Terraform was better, and now we have Kubernetes. And if you look at these kind of principles or the characteristics of a system, Kubernetes just plugs in. And that's not by accident, right? There's many people, especially younger folks that we talk to in the hallway track, they're coming and learning DevOps through the practice of using Kubernetes. Many of us were doing DevOps before Kubernetes, and it's sort of a reference implementation of those ideals. So it's important to understand why you use a tool to solve a problem. You might have read a blog that said, oh, go net cubes. Cool, Kubernetes is great, but it solves problems that we have inherently in system design. So we look at the KRM, the Kubernetes resource model, as this really powerful construct, right? And we say, we can do a lot of things with it. Yes, our workloads and the software we're running on this platform kind of benefit from all of these ideals. But the KRM is extensible. The Kubernetes itself is extensible. It's an open platform that we can all iterate on and we can all make better over time. So the question is, why would we have problems if in such an ideal world, right? We could build infrastructure, we can build clusters, we can have our workloads, we can have all of the pieces in this really great system with a platform and the software on top of it that all adhere to these ideal characteristics. So what is the problem? The problem is that most of us have a blended infrastructure as code, multiple tools, potentially multiple sources of truth in our system. If you think of the system as end-to-end, everything, soup to nuts, right? Dev clusters, prod, staging, UAT testing, everything, all of the pieces, plus all of the software components and the add-ons that run in the clusters and the clusters themselves. We have a blend, right? We almost always are using Terraform and Kubernetes. We might use ArgoCD for GitOps, but also CDK for infrastructure. So we have this pattern that we call GitOps, which is not a product, and it's not a star you put on the box for your product, right? GitOps is just a reference implementation of these ideals. So GitOps can be used to build the entire system, but most often with our customers at AWS, but also just in the hallway track talking, it's pieces and parts. Now, the talk right before us showed a full working system, right? That's an ideal system. Most of us don't live in that ideal world. So we don't often leverage the standardization layer of Kubernetes that we've adopted using our best automation for the entire system. So the remainder of this talk is to talk about why that is and to run a demo of some of the primitives that we think are really exciting, that need to be sort of solved problems in order to embrace this fully. So the we is us. So I'm Jesse. Amine's right off stage here. And we're going to talk a little bit about some of the things that we've been working on. And I'm going to get through the thought leadery stuff really quick. And we're going to get into some actual looking at code and looking at moving parts in a moment. But I do think it's important to think about why, right? So the complexity, again, we want to abstract the complexity. We don't want to hide it, right? We actually have to expose it through like kind of higher level primitives that respect the complexity for what it is, right? Like everything from RBAC all the way up through the life cycle of infrastructure and all of the software that runs between those 2 points, we have to respect that exists for a reason, and we can't hide it away. We could be in an ivory tower with a perfect system and look out at the chaotic world and say, oh, look, this is all perfect, but most of us don't live there. Most of us are down in the bizarre, in the chaos, and the fun and exciting world that is broken ops at 2 a.m. So we look back to this checklist of ideal principles, declarative configuration, continuous reconciliation. Why are they good things? They're good things all for independent reasons, right? So declarative configuration means that you're kind of binding these immutable artifacts and immutable source code versions against a known state so that you always know what you're running, right? 20 years ago, before everybody was doing this, it was pretty chaotic trying to figure out why prod broke if you couldn't figure out what change set you were running. And kind of going through this list, there's reasons for all of these things. And if you pull them into a system and you practice them all together, this is what we call GitOps. And I will say that GitOps, and a lot of us have said this before, it's not doing ops and using Git, right? GitOps is these 4 things. You check these 4 boxes, it's GitOps. It could be corn shell scripts running on a server somewhere in the corner of your lab, and you're doing GitOps, right? It doesn't require Kubernetes. It doesn't have to be ArgoCD. It's just that Kubernetes was designed with these principles in mind, so it's such a good fit. The KRM almost works this way already, so ArgoCD plugs in, or Flux, or other things, right? These Kubernetes add-ons plug in, and they automate the use of the KRM. So again, why don't we do it for everything, right? Infrastructure, clusters, the whole 9 yards. Throw everything in the cluster, let the bots sort it out. Why do we not do that? And in fact, we really don't. We see most often people are using ArgoCD, practicing GitOps for cluster add-ons, right? You build the clusters with Terraform or CDK. You have workloads through an imperative pipeline, maybe bash scripts and Jenkins. That works really well, right? And they're using GitOps for installing, KSM, metric server, things like that on the cluster. So you're kind of blocking this entropy and configuration of clusters in a really effective way. Why isn't it the whole system? And I would assert is because change is hard, right? Giving all of the control over to what feels like you still are in control, right? You're still building and shipping software, an imperative pipeline. It feels like you're doing it still. You're on your laptop, you push a change, the pipeline goes burr, and you're doing that. When you let automation fully take over, it's really uncomfortable. So what we see is platform engineering teams are at the forefront of this, using ArgoCD to manage their platform layer. How do we get the rest of the stack into the same system? So if we look at why we build microservices, why is this? This is a best practice. Why? Because it makes sense to break down fragile monoliths to accelerate our velocity and to make the system more resilient, right? This is a known thing. I'm preaching to the choir, I'm sure. So why isn't the whole system working this way? Because we don't have the primitives that you need. So if we look back at when Docker took, kind of the stage and came out, the thing I would argue that made that really take off was base images. The idea that everybody could be building from a Golang or a Python or a MySQL base image, and then you just build your app and ship it. That was really, really powerful. So there's this term that we call prescriptive resources, that actually is to platforms the same as base images are to containers. And you could build your own prescriptive resources. All you have to do with Kubernetes is build a controller and write a CRD, and you could do that. But I think as we're evolving, as more and more enterprises are using Kubernetes, we're looking at that pattern and saying, well, if I've got 12 or 15 operators that I have to maintain and own that don't implement business logic, does that start looking like tech debt? Right? Do I need to actually do all of that work and maintain all of that code just to glue resources together? So this is not a sales pitch, but this is one project that tries to solve this with a new primitive in the cluster, the Kube Resource Orchestrator. So this came from Amine and I actually talking about this very problem and wondering what we could build to solve this kind of problem of what feels like a missing feature in the cluster. None of this is super new conceptually, right? Like our friends in Crossplane have been doing this and preaching this story for like 6 or 7 years. But what we wanted to see was a primitive that everybody could build with, which is why I think the talks could have been flipped, because now I'm going down to a primitive where we just saw a whole working system. But everything that was in that the PCI clusters talk really reflects the same methodology here. So we're just going to skim really quickly through just so we have like shared context. So when you work with Crow, you create a resource graph definition that's kind of in 2 parts. One is you're specifying your API. This replaces the CRD, like having to author and maintain your own CRD, which is fairly complex. It just becomes part of the schema in an RGD. And then you specify your resources. So again, rather than having multiple resources and worrying about things like ordering and initialization and configuration dependencies, Crow solves that for you. You just write a stack of resources. You use cell expressions to elevate some of the configuration. You can inject across resource boundaries, and Crow figures out ordering. It manages all of that for you. So why does this matter? Coming back to all of the things I said before, prescriptive resources enable a self-service that is sane, right? We can actually create an RGD that hardwires as much or as little configuration as you like. So in this example, we've got an S3 bucket. Now what I want to be able to do is tell my developers, you can set the bucket name and you can tell me what region, but I'm going to determine the bucket policy, the lifecycle rules, and all the storage class settings. Right? So we put that in and we do not expose it through the API. So you end up with a very simple, compact little bucket. A developer needs a bucket, they get it. They want to name it, they can. They want to set the policies, they cannot. You do this versioned, you put this in OCI, and you distribute it through your organization, and now you have a Kubernetes native infrastructure as code implementation of your organizational best practices. So this is the piece that I think is missing. This is the piece that makes us feel like if we had this, we could sleep at night. We could get Slack messages in the morning about reconciliation rather than getting paged at 2 in the morning because somebody came in and overrode a policy that violated something, right? So this is the context for Amine to kind of go through some of the actual nuts and bolts of this. We started late, and we have like 10 minutes, so you. Thanks.
Hi, everyone. My name is Amine, and I am here for the live demo. So I'm going to get started by showing you a small example of what an instance looks like. And apparently, I need to reshare my screen in mirror mode. Can you see my screen? Perfect. So I'm going to show a small example in here of my cloud-native app. My cloud-native app looks like a Kubernetes resource. If you ever wanted to implement this behind the scenes, what you will typically have to create is a CRD and a controller. However, in our situation, we're not really doing any of that. There is no custom controller that handles cloud-native app lifecycles. There is no manually created CRDs behind the scenes. What I'm going to show in here is that I'm going to go directly modify the prefix in here just to say this is a live demo. And we're going to go and create it, see what happens behind the scenes, and then work backwards from that. So if I go and create my, I think it's 04 instance. Let's actually look at that before. So if I cat my instance first, I will look at exactly this file so I know what I'm applying. And if I do 0.4 instance, what we should see very soon is a bunch of resources getting created. One of them is a live demo bucket. So if I grep, you can see like here 2 buckets got created 10 seconds ago. If I go and look for S3 storage and grep live demo, I should see some. It should come back very soon, but the whole idea behind it is that when I submitted this cloud-native app, what happened is what we did behind the scenes is just submit an RGD, like Jesse described. What we described in here is our input. So in the schema we declared that actually we want a name, a bucket, an image, some replicas, and also some custom status fields. And behind the scenes, what we were requesting is an S3 bucket, an S3 storage class, a service account, a config map, and a web app application. And as you realize, like here, some of these resources have the API version crow.run, which themselves are also abstractions. So if I look at what is really a web app, it's just another file that describes what my web app is. And you can see here that we are defaulting everything to an Nginx image, and behind the scenes, our web app is just a deployment, a service, and an ingress. If I go and inspect actually my cluster, so if I go and look for all the RGDs or resource graph definitions, you will see that all of them are active, which means that they are served by the same controller. And if I look at CRDs, if I get only the crow ones, you can see that actually there are like 5 CRDs managed by the same controller. So the one that we created was called the Cloud Native app, and the sub ones that we created for this Cloud Native app are called, or like this one here is called web app crow.run. So if I look at my Cloud Native apps in here, what I will see is like basically 2 Cloud Native apps. One of them is working and the other one is not working. But the first one in here is basically, if I look at Cloud Native app and I do -o YAML, I can see that it actually like published a bucket arm for me and a number of available replicas. And if I look for pods, for example, or deployments, I will like see that my kubecon service has a deployment ready 3-on-3. Yeah, that's it in a nutshell. We're creating abstractions with other abstractions. There is only one native thing called kube resource graph definition. And behind the scenes, what happens in here actually is that Crow does a lot of static analysis behind the scenes and make sure that actually your RGD makes sense. Let me show you an example. If you look at, say, the web app application, so if I go and look up this one in here, I will see that it stays like state active. Actually, let me do RGD. There is some interesting things that happen behind the scenes, and one of those things is the topological order. As you've observed, in the name of the CRD, there is graph. So everything behind the scenes is a graph, and things will be deployed in a specific order, meaning that here Crow like realize that there will be a deployment, then a service, then an ingress behind the scenes to be created. Even though, like, if you go and in your web app, let's say you put a service before a deployment in here, but what happens behind the scenes is that Crow looks at all your cell expressions, inspects them, for example, here in the service, or the ingress. You will see, like, here the ingress depends on the service. So there is a direct dependency, and Crow knows that an ingress will always come after a service. The other interesting part about all this stuff is the static type check-in. If you look at this YAML file, it's very hard to understand that actually there is a problem, or let's say, it's very hard to understand, like, how replicas is really used inside your YAML, and it's very easy to miss what's going on. So if I take, for example, replica, and I put it, let's say, in the metadata.name, which is technically wrong, because you cannot put an integer into a field that is only taking strings, and I go and I apply this one in here. So if I do -o, so let's go create the to web app. You can see here that web app instantly became inactive, and if I go and describe the web app.crow.run, we can see exactly what's going on. And it says, like, hey, I'm not going to let you deploy this thing because in the deployment, you're trying to use a type integer in the metadata.name, which is, we expect in this field, a type string. So behind the scenes, Crow does a lot of static type check-in, understanding your DAG, understanding your types, understanding how everything is related before starting to serve your new type. And yeah, one last check. I'm going to see if this eventually worked. Cloud native app. Nope. So this is like live demos. Things sometimes break, and it broke today. I'm lucky that I had another one that was ready. But yeah, this is in a nutshell how Crow functions. And Jesse, leave it up to you.
So we just have one more slide. We're just about at time. We wanted to leave a little room for questions, but we got started late, so we'll be around. We'll be around the conference as well. But yeah, the idea here is a simple one, but what we're hoping is that you see this as a primitive that you can take with you in any system that you have, right? And everything we just showed can work with a number of things. You could dovetail it into like a split brain Terraform and CDK for some things and KRM for others. But if you embrace Kubernetes and the KRM for all of this, there's a number of solutions around this. This is a pretty nascent space. There's no de facto standard right now, right? So you can work with third-party products. You can work with open source projects like Crossplane. You could bring the infrastructure in through these building blocks, but the building blocks are also good for any type of resource. So maybe you already have your own operators, your own custom pieces. You can also use Crow for that, right? So this is hopefully a really interesting piece of the platform for you to consider. Thank you so much. You can find us on GitHub. We are on all the Slacks as well. And if we see you in the hall, trip us and catch us for a conversation. We're happy to talk. Thank you so much.